Okay, so just a quick update on my GCU replacement project. In the background you can see my Red Wolf rifle, and in the foreground you can see an example of the GCU PCB. That little silver thing down there is the brains of the operation. It's an ESP32C3 wireless microcontroller. Now, hopefully you can see this. This is the WebUI that I've been working on for a while. It's taken a bit of effort, but it seems to be getting close to something we could use. So this is the settings page where we can set up various settings, I suppose you would say, including a username that's displayed on the LCD at power up for a bit of fun, the tune that we're going to currently use. So I have a fictitious slug profile, I have a high, a mid and a low power profile. I can select one of these and update the GCU in a moment to tell it to use that one. I can also change the size of the magazine counter. The magazine, which is useful for the counting, useful for counting pellets, let you know when you're out of ammunition. The backlight timer, backlight brightness, so how long the backlight will run for, how long the backlight will run for after it senses no activity. So you put the gun down after 15, 20, 30 seconds, the backlight turns off to save a little power. Backlight brightness, as I say, after 15 minutes the GCU will turn itself off, and we can change that number. Also Wi-Fi SSID for your access point, and the access point SSID when the GCU is acting as an access point, and I'll get into that later on in the project. So what we can do for a simple test, for example, is to change this and your name here. So that will be displayed on the splash screen when the rifle starts up, and I'll show you that in a little while. So we'll update the GCU, and it's just asking for confirmation. So we'll say OK. Update's complete. Now the GCU has been updated with our new settings. In the tuning tab, we can edit the tunes that are loaded into the GCU, and at the moment we have our fictitious slugly profile, high power, mid power. So if I go look at high power, those of you who looked at my other post previously might recognize some of these numbers. This is the high power profile from my Red Wolf, and similarly I can then look at the low power. I can change these settings. I can change the name, and I wish I could do a better job with web than this, but I can change the name, update that, send it to the GCU. Okay, go back to settings, and yeah, the name's changed. So back to tuning. What we can do here is we can set the pressure point, the high, mid and low set point pressure, and the dwell time for the hammer at those set points, and then there's a bit of interpolation that goes on to go from, as the pressure drops between these points, it calculates a new dwell time, which is explained in my other post about the GCU. We can also set the boost voltage. Now down here in the update tab, it tells you which software is currently running, and what the previous version is. And this is an A/B system where we can flip between firmware. So if something's wrong with the new firmware, the bootloader should detect that and allow us to boot the previous firmware. We can update, we can download our settings, we can download our tune, we can also upload our settings and upload our tune. We can back up and restore the settings and the tuning data. And then on the override page, and I'm not done working on this yet, I need to just adjust the camera a little bit. So across the top you can see the status, which is green, okay, the boost voltage, which is 64 volts, the pressure, which is 241 bar, and the dwell time. Now the dwell time is 2035 there. If we go back to settings, we know we've got low power selected, and in tuning, when we look at low power, high set point at 251 bar is 2085 microseconds. And in the override window we can see we're about 2035 microseconds for 241 bar. So you can see the interpolation is working. We're starting to drag itself down. But one of the things that we can do in here is override the dwell. So instead of the dwell being calculated by an algorithm based on your tuning data, you can manually set the hammer dwell. Set whatever value you want. And you can see it's changing here. It's got yellow to indicate that it's being controlled. As I say, I'm not completely thrilled with this web page yet, but it's a work in progress. And we can set the value that we want the dwell to be. And when we fire the rifle, that's how long the hammer dwell will be. And we can use that to find the perfect dwell time at a particular pressure to get the pellet speed we want. And then there's another feature here which I'm quite pleased with. I've just implemented. So this is my degas feature. When you're tuning, it's convenient to be able to step down in pressure for like 10 or 20 bar. So at the moment we're at 241 bar, and I'm going to command the rifle to degas itself to 230 bar. So when I hit the degas button, I think you can hear that. My adult beverage out the way. You can see the rifle's firing. And the pressure is slowly falling. 236, 235, 234, 233, 232, 231, 230. And it's done. And we can take a quick look at the rifle LCD, and we see that that agrees 230 bar. Okay, so that's the WebUI. Now I'm just going to stop for a moment and show you the LCD.